this, and we use the product rule. You might just want to put that down. That's showing the product rule. But now when I am looking at this, especially right here in this first one, do you see the composite function? Take a moment. And again, looking at this binomial cubed, if I told you that x had a value of pi, what's the first thing you would do? Would you raise it to the third power? No. You take 3 times pi minus 7. So your inside function, and if you need it, do what I'm doing, write down here, this is the inside function, is that 3x minus 7. The outside is something cubed. So to take the derivative of this, we start by, and again I could put the little smiley faces up here, it's something cubed, so how do we take the derivative of something cubed? Okay, and then we have to go back and say, well, what is that something? In this case, it's 3x minus 7 times the derivative with respect to x of the inside function. And so that would be the derivative of 3x minus 7. Plus, and I have then my 3x minus 7 cubed, and my derivative of x with respect to itself is 1. Is 1. Okay. So let's see, I've got x, I've got 3 times this quantity squared, and now I just have to take the derivative. By the way, I'm going to go over here and write down, this is the chain rule. Okay. What is the derivative of 3x minus 7? 3. Okay. Plus, then I have 3x minus 7 quantity cubed. Now, as I said on the videos, once you have shown me all of the derivatives you're taking, and you have taken all of the derivatives, then you owe me, you're required by my rules, to show me at least 2 algebra steps. You can do more, but at least 2. Yeah, Scott?
Is it okay to put the last 2 steps in here and the 1 step, all the derivatives by 1?
I would hesitate to say yes on that. Okay, you might be what might be the exception to the rule, but I can guarantee you that there's a majority of the students who would not have they'd get so messed up with that, it'd be impossible. So I just recommend that you write it out. Okay. I realize for some of you, you can maybe do 2 or 3 steps, and I will allow you to do that, but not at this point. Okay, so now let's see. I've got 9x, and I've got 3x minus 7 quantity squared plus 3x minus 7 quantity cubed. Yeah, that's 1 step of algebra. But the next one, let's see. Got a common factor. Good. Let's factor out 3x minus 7 squared. And that leaves me with 9x plus, and I still have another factor of 3x minus 7 in there. If you need to, put a parenthesis, so it's 1 more factor of 3x minus 7 in there. That's 2 steps, but come on, let's do 1 more. I don't expect you to do any really heavy factoring, canceling, finding the common denominators, but for things like this, we have that. Elvin, I saw your hand up first. Is there a question? Just stretching? Okay, Jordan?
Is the x just can you get rid of it?
Did I?
Above it.
Right here? Oh, I did 3 times 3 is 9 times x.
Okay.
Okay? Now, once you get an answer, these, especially starting here, actually it's 3.2 and 3.3 you need to start, we have got to check our answers. We've got to check them. So let's go back and just make sure everyone knows how we're going to check these. There we go. Pick up a new document if you haven't done so already. And we're just going to add a calculator page. Is everyone aware of where to find the derivative template? I think I gave it to you on the video, and hopefully you found it. probably, for me, the fastest way is go to menu, go down to calculus, and then you have derivative. Okay, our derivative, again, what's the input variable? And it is x. Okay. Always, always, always go back to the original problem. We can make so many mistakes if we don't go back to the original problem. So go back to the original, and we've got x, and just because it doesn't hurt, you won't use up too much batteries on the energy in the batteries to do this, put a multiplication sign in there, just to make sure. And then what was this, 3x minus 7? And make sure you move outside appropriately before you raise it to the third power. Okay, once you have it all in there, double check, make sure, did we do it right? Now this one comes out to be exactly what we have. Trust me, they're not all going to do that. And so if they don't come out looking just like ours, remember we go up, we grab that answer, we find the equal sign, and we type our answer behind it. If they are equivalent, we hope the word true comes up. Okay? Now that won't happen for all of yours, and it's because of the complexity of maybe some rational functions in there or some radicals in the denominator. You may get a few that won't come up to be true because you have multiple answers that could possibly be there. But it will be, for the most part, it'll come up true. Yeah, Peter?
Why do you get an error if you don't put in the multiplication sign?
Did you get an error?
Yeah.
Okay. Sometimes it doesn't understand the implied multiplication. And so I don't know if when it is or is not, but I just kind of always put a multiplication sign in there because I know sometimes it doesn't understand that. Okay, well let's go on. Again, the first thing we had to do was recognize this as a product rule, and then we have the composite function as the second factor, and that's where the chain rule comes in. Let's go on. Here's that generalized power rule I was telling you about. Okay, so y equals u of x. U of x is to the nth power. U is the output of the second or the outside function. X is the input of the whole problem there. Again, this piece right here would be the output. This would be the inside function that we're talking about here. And so I said that incorrectly, I think, before, but this is our inside function here also. And so du dx would be the same as u of x. Okay. So we basically have the same thing going on here that I've been showing you. I like combining those. Okay. So let's look at this problem. First of all, do you recognize the need for the chain rule? Now again, you might say, well, let me test it out and see. If I gave you that x had a value of -1, what's the first thing you would go to? The first function, the first action you would take would be to put it into the quotient here. What's the last thing you would do? Yeah, raise it. So the inside function is the quotient, the outside function is cubing something. Now, when you talk about now taking the derivative of the inside function, you're going to have to use the quotient rule. Okay, so we got the chain rule, and then we have the quotient rule. So let's take a look at this. The derivative of this is going to be, didn't realize until today, all of my examples are cubing something. We should have had something mixed up a little bit, but you understand that not every problem is going to be cubing. Okay. So again, cover that up with something mentally or physically. Something cubed, its derivative is 3 something squared, and then go back and fill in what the something is. So this is the derivative of the outside function. And then we have to take the derivative with respect to x is because we have the variable x there, of the inside function. And so the inside function is 3x squared minus 1 divided by 2x plus 5. What rule have we just used? Yeah. And again, you can just call it all the chain rule for me. You know, the other one is called generalized power rule. We're chaining together derivatives, so we'll call it the chain rule. Okay. But I'm not through with writing the, yeah, let me try that again here. I'm not through writing the, out all the derivatives, because now I've got, 3 the quantity. I've got to write this down. I know. It takes time, I realize, but we have to do it. Now the derivative of the quotient is what we have to focus on. And this is now your review on the quotient rule. I hope that you've looked at that video. I hope that you found your own way to remember what the quotient rule is. Remember, we start with our denominator, and for me, I remember that because D for denominator comes alphabetically before N for numerator. So it's the denominator times the derivative with respect to x. Must you write this out? Yes, you must. Okay? Because this is telling me that you know the quotient rule. Okay? So you must have this line in your work. Now the big question is it adding or subtracting? How do you remember that? Okay, hang on. Kendra again?
With x, y, and z, if you end up subtracting into it.
Okay, so if you have some way of remembering that, it's important. Minus the minus the numerator times the derivative with respect to x of the denominator. Am I done? Yeah, all of it divided by the denominator squared. Okay. So yes, you must show me that line. And again, this is the quotient rule that you're showing that you understand. Okay. You don't have to, no. You don't have to. I mean, I'm sure you know what they are, but you don't have to. Okay. Let's see. So I've got 3, the quantity, 3x squared minus 1 divided by 2x plus 5, that quantity squared. And now I work on this. I haven't taken all the derivatives yet. Let's see. I have a 2x plus 5. And now the derivative of 3x squared. How about 6x? Okay. Minus 0. You don't need to write that down. Minus 3x squared minus 1 times the derivative of 2x, which is 2. All of it divided by 2x plus 5 quantity squared. Okay, so now we've taken all the derivatives, and we need to take at least 2 more algebra steps here. Okay. This would be 3, the quantity, 3x squared minus 1 quantity squared divided by 2x plus 5 quantity squared. And now I have 12x squared plus 30x minus 6x squared plus 2 divided by 2x plus 5 quantity squared. And while you're looking at that, because